So guys, hi to everyone again. So let's start. And I want to announce about the joining the meetings during the lecture time. So you have to so let me share my screen. You have to just wait until the lecture starts, the meeting. So the title of the meeting will be the lecture number 5, for instance, in the next week, lecture number 5, and your group is G3. And you have to only join that group. So concurrently opening and running the different meetings during the lecture time will be misunderstandable for others, and they can just miss the lecture time, and that's why just wait for the starting of the lecture in our channel with this title that we can start in the next week. Okay, and now so now we can start examples. Today you have to finish the previous lecture titles like 1D arrays. So examples from the 1D arrays, and so the week number 3, or sorry, 4, and we have the group 3 for you. And let's prepare our file. iostream. Return 0. Okay, we already discussed about the creation of the arrays and what is the array and so on. So let's continue working with the examples. Show even numbers given from arrays. So the odd position starting from this example. So you are given an array. So given an array, for instance, 4, let it be the 7 and 7. So there is the input, and output should be, in our case, output should be, so it says the odd position elements from a given array. So the position of the elements is 0, 1, 2, 3. So you have to print out only 1 and 3 because 1 and 3, they are the odds. The output should be the 4 and 7. So I think the task is clear for everyone, and we will start reading the data. So integer n and reading n. This is the first number. And after that, we have
4 and 8.
Sorry, say it again.
4 and 8.
So
Even
why this output should be? Because so indexes are here 1, 2, 3, 4. Oh, sorry, 1, 2, 3, 0, 1, 2, 3, and it says odd position from given array. So the positions are here, and we have the odd positions. Odd position is 1 and 3. These are the indexes.
okay.
Indexes, and we have to select indexes only, odd indexes, and the result is 4 and 7. Not show the not index, but the value of the array with the odd indexes. So that's why this number should be the output. So we read only the number n, and after that, using the 4 as we did before, we have to read the values of the array AI. And after that, let's do the separate for. You can do it inside of the 1 for, but for the clear understanding, let's do it as a separate for I and I++, and inside it, if I is divided by 2, equals to the 1, which means we are checking the indexes. I, in our case, it's an index. We are checking the indexes for the odd or not. If I is odd, in that case, we want to see out. See out, not I, we have to print out the AI, which is a value itself. You can compile it and run it. 4, 3, 4, 8, 7. And the result is here, which is a correct result. And every time when you are working with this type of tasks and entering each time these numbers, input numbers are not comfortable. That's why we have the option for working with the files. File, let it be the in.txt or input.txt. Input.txt. And inside of this file, we will hold our input with the needed values. So we're saying before everything, after the int main, we have to open the free open. Free open, it's a already defined built-in function in C++, which you give ability to read the data from the input file. So it will take the free arguments. First one is the name of the file or path to the file. Second one is mode. Mode might be the R or W, depending on your need. R, it's a read. R means read the data. And the last argument should be the std in or std out, depending on your task. Again, std in means we want to read the data from this file. So input.txt file, which is defined here, which will hold the result, so the input data. And it says, for our program, we want to use this file as an input. And try to compile it again. And if you run it, you don't need to enter again the files. So enter again the data. So it will just read the data from this file and the output over here. And for instance, if you are changing the file and running again, you will have the result over here. So it will just read from this file, which is comfortable when you are working with this type of the tasks. You can even create output file. Output file, which will say that output.txt file, the mode should be the W, which means W means write. And std out should be, because we are writing to this file. Even you are not created this file yet, after compiling, if you run the program, this file will be created for you and it will hold the result of your program. So which means all the couts that you are writing in your program will be couted not to the console, but to your output file. For instance, here the cout hello. Let's compile it. Oh, sorry. Compile it again and run it. And you will have the such like results, which means all the couts will be just printed out to the output file. And these two lines will be comfortable for this type of tasks. So the next example about the counting the number of positive numbers. So the counting the positive numbers, which means so let it be the -7 here, and the result is 3. So 3, 4, 5, the number of these numbers, positive numbers, is 3. So input file will hold the -7 here, and the result should be the 3. So input output, they will be the same. So the reading part will be also same. And we have to just create here the one more variable for counting, which is equals to the 0. And even you can do it inside of the reading part without any extra 4. You can do it inside of the reading part, which means you can read the data. So you can read the one by one values, these numbers, and immediately compare them. AI, if it's more than 0, in that case, we want to see in T++. And after the reading part, you already got the result. which is over here, and you have to print out. If you run it, you will have the number 3, which is the output of the current problem. So the next example is finding the minimum and maximum from the given array. So let's do the same example, same results here. We'll have to find the maximum and minimum. So any ideas how can we do that? So we have the reading part here. So the reading part here, and we have to somehow identify the minimum and maximum from this given list and print them out. Any ideas? Guys, any ideas how to find it?
Minus equal to 0.
Sorry,
0.
so the
0.
maximum equals to the 0. Let's try to do like this. For integer I equals to the 0, I less than n, I plus plus, and inside it I have to compare like something like this. AI, if it's a more than maxi, in that case update the maxi of the value. So I'm putting here the 0 as a maxi, and I'm checking the maxi size. And if you run it, let's try to compile it. And if you run it, you will have the maximum as a 8. So where is 8? Oh, I forgot about the printing out the maxi. Compile it again and run it again. You will have the 8 as a maximum. This is correct. But what will be if we have the such like input? So if you run it, you will have 0, but with 0 don't have any inputs here as a maximum. Why?
Because we said that it will be more than
Yes.
0, so it will equal to 0, but our numbers is less than 0.
Yes, of course. That's why this program, your program, this solution will be work only we have at least one positive number more than 0. But we might have such like an input, and in your program you will have the wrong answer for this solution. So how can we correct this problem? How can we manage this?
I more than n, I minus minus for int I.
So say it again.
We need to write A0.
A0 is correct solution. So A0 means we are taking the maximum as a first element of the array. So we are assuming that the first element of the array is maximum. And we can start from the 1 and compare the results. If you compile it, you will have the correct solution. For instance, from this case, we have the -3, it's the maximum number. If it's here the -10, in that case, you will have the -4, which is the maximum number from this input. So this type of the logic will be the correct for any solution for any input, even we don't know how many elements and which numbers we have inside of the input. That's why this solution is commonly solution, and we can do it for the mini again. For instance, for finding the minimum number, you can again take the first element of the array as a minimum number, and after that try to find comparing the results. For instance, if AI is less than mini, in that case mini equals to the AI, and after that print out AI, mini, printing out So here I have the input and here I have the output. -4, it's a maximum, and -10, it's a minimum. So I think this is clear. So pay attention that for finding the minimum and maximum, it's recommended to use the first element of the given array as a maximum or minimum and try to compare it with the other rest of the rest of the values. So the next example is linear search for the number k. So let's do it like number 8 and number 8 here. So the number 8, it's just a searching number, and you have to print out yes or no. If 8 is occurred in this list, you have to print out yes. Otherwise, you have to print out no. This is solution. So this is a task for the finding the numbers. So the linear search. So the input is like this. You have to read the input. So the input part will be the same as before, but we have to add one more scene value for the k. So let's create the number k here. And after the for loop, after the reading the elements of the array, you have to separately read the number k. So the number k out of the for. To be clear, you can do it like separate it like using the curly brackets. So which means for loop will finish and finishing the reading the arrays elements, and after that you can read the number k. So after reading the number k, you have to start searching this number k in your array. So in your array, which means a starts from the 0 until the n, and inside it, if ai, if it's a current element of the array, if it equals to the k, I have to do something. What I have to do?
Shout yes.
So cout yes. And when I have to cout no?
Else.
So else cout no. So if you compile this file and run it, you will have such like an output. Why? Because what we are doing, we are taking the current element of the array and comparing with the k. If they are equal, I'm counting yes. If they are not equal, I'm counting no. Let's see our input. So the 8 and 3, they are not equal. So we have here the output no. So 8 and 4, they are not equal, we have the no. So 8, 8, we have the equality, we have the yes. And for the last element, we have also the no. But from our requirements, we have to one time only print out yes or no. Do we have this element in a given list or not? So how can we manage this?
We have to write break.
Where?
Return 0.
Where?
After cout yes.
After if and after else.
If you are breaking out, else part, I have to remove it from this. Why? Because so if current element is not equal to the k, it doesn't matter. You have to print out yes, because the current element is not equal to the k, but this k occurs in the rest of the array. That's why this else part is not correct inside of the if. So ai equals to the k, counting the yes and breaking. Break means this for will just finish the working. So in this case, when I have to write cout no,
After the break?
so after the break, it will just skip the rest of. Break means it's just finish this for loop and go further.
We can write else if.
Else if.
So else if, what I have to write inside if?
Else if a AI not equal to K, cout no.
So AI not equal to K, it's just the else part. It's the same thing as like else. But else is not correct for us as we did before. If the current element is not equal to the K, it doesn't matter, you have to print out no. Say this example. So 8 and 3, they are not equal, but output is yes. Sorry?
For example, if I equals to K will equal to 1, ну, true.
Okay.
Ну, bool использовать, короче.
Yes, you can say it in other language.
Ну, и мы используем bool, и если она равняется K, то bool будет равняться единице, и сразу break происходит. А если она будет не равняться, ну, как бы, K, то bool будет, ну, как бы будет, bool до сих пор будет равняться нулю, и под конец операции он все равно будет равняться нулю. И получается, мы можем, ну, как бы написать, если bool равняется нулю, то no. А если есть, yes. А если равняется единице, то да, написать yes.
Okay, Ramses, perfect. The solution is correct. So the Ramses suggests to create a Boolean value. The flag equals to the, let it be the false. So at the initial point, we have the Boolean flag, assuming that we don't have any K in our list, in our array. And inside of the if, if we have the such like equality, so the AI equals to the K, in that case, so we can change the flag value to the true. Flag value to the true. And we can also remove this one or leave it. So if you remove this one, you have to write it after the for loop, or you can just leave it like this. So the changing the flag to the true and counting the yes and break. Because if it's equal, if AI equals to the K, it means you have to always print out yes only once. And after the for loop, we are checking if flag value stays as a false, which means this if condition not executed. In that case, we have to print out no. And that's it. That's right. So the for CPP, if you run it, you will have the yes, because 8 is exist. 9 is not exist, that's why is no. So the 8, and for instance, here we have the one more 8. If you run it, you will have to one time yes, which is also correct. So this is a correct solution. So you can do it like this. For instance, removing this yes and without break. If you found the equality of the current element and K, you have to change, and you change the value to the true. And if flag stays like a false, in that case, no. Otherwise means flag changed value to the true. In that case, you have to print out yes. This is also correct solution. So this one and the previous one, they are the same. So that's why let's copy this one and put in a new file. So the for and 1 CPP as a next solution. And as a first solution, we have to stay like with the break. And we can also, someone says about the returning 0. So let's try to returning 0 as example also. The same example, so the same task. And how can we finish? How can we work with them? So without any flags. So we are searching for the number K. If we found the number K, we are counting the yes. And instead of the break, we have to return the program. So the returning the program, in all the examples that we did before this example, we are just writing at the end of the main function. What does it mean? This returning 0 means just finish the program and close the program. And we're saying here manually. So if we found such like a number, cout yes and finish the program, which means this rest of the code will be just skip it. And if this if condition is not working, which means if the for loop finishes until the end, in that case, we cannot find any k inside of the array, which means we can just print out a no. And you can try it again. If you run it, you will have the correct solution, which is over here. Yes. If it's a 10, which is no. So as you can see, we have the 1, 2, 3 solutions for the same problem. That's why try to find the best and best solution for you and for your speed as finding the solutions. 5 CPP. So, okay, so learning the linear searching. So the removing this one is for you, and let's try to start working with these strings. So input is one given string, hello, which can contain some numbers. So the 3, 4, and 9. And output should be 3, 4, and 9 like this. So they show all digits from given string. So the task is like this. And you are given one string, which means string word. And we can see in the word. So before this fifth example, we created here the list of items. So the list of, so the array of integers. So the array of integers, but string itself, we know that string itself is just an array of chars. So the list of chars. So the age is one char, 3 is second char, 4 char, E, L, L, 9, O. Each of them is one element of the array. So the string itself can be considered as an array. So that's why you can see the function called the string word size. For instance, for kbtu, it will return the 4 word, and for instance, this mark, you can see that the 5 elements. So the size returns the number of chars for the given word. For instance, word 0, as we did in our examples, in our arrays. It's just starting from the zeros index as we did before. Hello. The zeros element, it's just the age, which means we can, using the square brackets as we did in the simple arrays, we can work also with the strings as an array of chars. So which means we can also work with the for starting from the 0, I works with the word size, and I++, and counting the word, each element, for instance, for within the spaces. Fifth element, for instance, hello, which means, as you can see, we can separately access to each element of the word as in separate chars. Okay, this can be understandable for you. So, so any ideas how can we solve this problem? So you are given such like a string, you have to print out only the digits. Any ideas?
If word I equals to integer, then
we don't have such like comparison, so we cannot write like this. If word, so the word I equals to the integer. This is the incorrect comparison. It cannot be compared like this. We don't know that word I is integer, so this is the question, how can we identify it? But this condition is incorrect. Any other ideas?
Помните, вы говорили, через у чара есть определенное количество цифр, и, например, какая-то определенная цифра равняется какому-то определенной букве или цифре тоже самое.
Perfect, Ramzes, perfect. There is a solution like this. So we talked about the ASCII code of the chars. So ASCII code of the chars, as we can see in this table, we have the separate chars, and for each char we have the ASCII code, so the decimal code. For instance, for the 0 we have the 48 as an ASCII code. For the 9 we have the 57 as an ASCII code. Let's check it. For instance, 0 is a char. How can I take the ASCII code of this char? I have to put just the integer before the value, before the char. So let's write. If you compile and run it, you will have the ASCII code of the 0, as you can see from this table also, this one. And 9 is 57. Let's check it. 9, compile it. And as you can see, the 57. Okay, perfect. And we know about it, and all the digits, 10 digits starting from the 0 until the 9, located in this range of the chars, in this range of the ASCII table. So using this ASCII table, you can identify the current character, is it digit or not. So how can I do that?
Using loop.
Inside of the loop, I have to create. So let's create the number code, and number code will be the integer of the word I. So I'm just getting the current character. Word I is the current character, and converting to the integer, which means getting the ASCII code of that character, like we did here. And after getting the code, I'm checking if the code is located in the range of these numbers. So it means, what does it mean? It means we have the number here. If the code located in the range of 48 and 57, as we know from this table, they are all numbers. So in that case, you have to just print out word I. Let's write. So I'm putting here, as you can see, we have only numbers. I think this is clear, and we can continue working with the next example. So the next example is just very similar to this one. And in this example, you have to do like this. You have lowercase word, and you have to convert it to the uppercase. You have to convert it to the uppercase. So the task called the convert the all letters to upper. So you're given one word with the lowercase letters, and you have to convert it to the uppercase. Let's see that to the table. I'm talking about the hints, and how can we convert the lowercase letter to the uppercase? So, any ideas?
We can just minus 20 of the ASCII code symbol.
Sorry, say it again, Andre.
We can get minus 20 of the ASCII code of every symbol.
So minus 20. Why 20?
Because the
22.
difference between upper and lower case is 20. No? Wait.
So,
I'm sorry.
so
I've looked at the hexagon code. Not 20.
So the lowercase letter ASCII code A is 97. Uppercase letter A is 65. So how can I get from the 97 to the 65?
Minus 32.
Oh, minus 32. That's the correct solution. So if I am getting the uppercase letters, if I am getting the minus 32 from this ASCII code, I'm getting the uppercase. Let's test it. So the D is 100 minus 32, it's a 68. For the A, for the other values, they are just listed one by one, and they are listed by the alphabetical order. That's why it's enough to identify the constant that we have to subtract. So the constant is 32. So let's try it. So we are getting the ASCII code of the current character. So ASCII code of the current character. So the code is character. So and code should be code minus 32. It's the same thing like minus equal to the 32. So and after that, if you are printing out the code, you will have the such like a result. So it's a 6 example. So the hello, and you will have the such like a result. Why? Because 32, or sorry, 72. If you see the table, 72, it's a uppercase H. From our input, it's a hello, it's the first symbol. Second one is E, and ASCII code says 67. Oh, sorry, 69. 69, it's a E. So always all these correct, but the output is not comfortable for us. What I have to do?
Write char before code.
Yes, I have to convert it back to the char. So we are converting from the char to the integer and doing the mathematical operation. And after that, convert it back to the char and try to run it. And you will have the result. So, okay, this one is understandable and I think clear for everyone. And what will be if I am writing like this? Hello. So the sum of the chars already uppercased. So if you run this code, hello, in that case, you will have the other symbol in the symbol of the position, which was already uppercased. Why? Because we are always
from 0.
Yes, we are always subtracting the 32, even this word I is uppercase. So for instance, uppercase letter H, it's a 70 or 72. So from the 72 minus 32, it's a 40. In 40, we have the this symbol. As you can see here, I have the this symbol. So we are subtracting without any comparison, always subtracting the 32. So how can I manage this problem?
I equals to 1.
Если больше и меньше там определенных чисел.
If what?
We should add a condition
Condition for what?
for the uppercase of the letters.
So this operation, so the code minus 32 should be in which condition should be executed?
If ASCII code of the symbol is in diapason of uppercase letter.
So I think this would just opposite one. If it's a lowercase, isn't it? So we have to subtract the value
Yes.
32 if it is in a range of the lowercase letters. So if it's a lowercase, only in that case I have to subtract the 32. Isn't it? Do you agree with me?
Yeah.
So, okay. So I have to identify the range of the lowercase letters as we did in the numbers. So for the numbers, it's 48 and 57 for the identifying numbers. For the lowercase, it's a 97, and for the dead, it's a 122. Which means, after getting the code, I have to check if code is more than 97 and code is less than 122. Only in that case, I have to code minus 32. So in other cases, I have to just skip this calculation. Let's try it. Hello. As you can see, this is perfectly worked for this input type when you have the already uppercase letters. So we are working only in these three sections when we have the lowercase letters. When we have the lowercase letters, we are changing the code of the this current symbol. If it is not, in that case, we are just sending it back without any changes. So they're converting to the integer and sending it back to the chars. I think this is
Sorry,
also
I
clear.
think we-
Yes. Say it again. So, okay, this is the last example for the first hour of today's lecture. And time to your questions, please. Questions until the sixth example. Raise your hand, ask your questions. Okay, if there are no questions, so in that case, we'll take the 3-4 minutes break and we'll continue as a second hour of today's lecture. Okay, guys, so let's continue. Let's continue and see the examples from the lecture number 3. Oh, sorry, 4, which regards to the two-dimensional arrays. Two-dimensional and multi-dimensional arrays. So the 7th example. So before the two-dimensional array, we have to talk about the nested loops. So the nested loops, turn off, please, microphones. Okay. So the nested loops means when we are working with the 1D arrays, just simple arrays, as we did before, we are working only we're using the for loop for the looping over the array, whole array. If you are writing the one more for loop inside of this first one, for instance, the for until the 4, so the j++. In that case, you will have somehow the metrics of the values. So the cout. So to manage the indexes, let's see out here the I. So the I equals to the I, and handle cout j with a space. And after the inner for, let's see out the handle to print out the new line. So let's try to see the example, so the output of this code. So what it says, so the I, it's the outer for loop, works from the 0 until the 2. So the I equals to the 0, and for the I equals to the 0, inner for loop will finish one time, hold the working. So they're starting from the 0 until the 3. As you can see, the 0, 1, 2, 3. And after finishing this for loop, we are printing the new line, which means the next iteration will start from the new line. And for the next iteration, I will be changed for 1, and it becomes as a 1, as you can see. I becomes as a 1, and then for the I equals to 1, this for loop works again, starting from the 0 until the 3. And for the next iteration, I becomes as a 2, and again this for loop will work for this I equals to the 3, I equals to the 2. What does it mean? Which means for the outer loop values, for each value of the I, this j for loop will finish each time again and again. So let's see another example. In this example, we want to print out like this. We want to print out I and j like this. So in that case, you will have the such like output. So the 0, 0, 0, 1, 0, 2, and 0, 3. First number is I, it's an outer loop variable. Second number is j, which is the inner loop variable, iterator. And after the inner loop, we are printing out the handle to start the next iteration in the new line. So what is going on? Let's see in this picture. So we are working with the indexes, and we are working in the indexes of the two-dimensional array. For creating a two-dimensional arrays, so let's copy this one and 9 CPP. For creating a two-dimensional arrays, the rule is the same as we did in a one-dimensional array. We have to write the data type of the array and the name of the array. If you put it like this 4 or 3, here you have created a one-dimensional array. To create a two-dimensional, you have to put one more square brackets and put a number. So in this case, you created the matrix, which consists from the 3 rows and 4 columns. Let's see this picture. So int a, 3, and 4. And we created such like a matrix. 3 rows, first row, second row, and third row. And 4 columns, first column, second column, third column. So the first, second, third, and fourth, 4 columns. So this is the example for the 1D array, what we did before. Integer A5, it means we are just creating the one line which stores our values. It's somehow the two-dimensional array with the 1 row. So the 1 row and 5 columns. It's a 1 row and 5 columns, as you can see. It's somehow considered as a 1D array. But instead of the 1, we can do it with other numbers like this, 3. In that case, you will have such like a picture. And as we know from the 1D array, indexes starts from the 0, 0, 1, 2, 3, 4. And for the two-dimensional array, they will be the same thing. So the 1, 0, 1, 2, 3, it's the indexes of the columns. It's a zeros column, first column, second column, and third column. The same thing for the rows. First row, second row, and third row by index, it's a zeros row, first row, and second row. So, so this is just a creation of the two-dimensional array, and accessing to the elements will be the same as before using the square brackets. And inside of the square brackets, you have to set the index of the needed value. So let's start for accessing and assigning the values. For instance, to put here the value, you have to set the index of the row. It's a zeros row and a second column. A zeros row and second column equals to the 5. Continue. So the 10 is first row and first column. First one is the number of rows. So the index of row. Index of row and index of column equals to the 10. The next element is -1. The index of row is 2 and 1. 8, 2, and 1 equals to the -1. And here I have the 2 again in the row 2 and 3. 2 and 3. So we already set it for some cells of our matrix. Not all, but some cells, the values. And how can we print out our matrix? So the printing out, as we seen in a previous example, indexings, in previous examples, we have to write a nested for loop, as we did before, nested for loop. And in this picture, you can see the indexes for each cell. For instance, this cell index is 0, 0, 0, 1, 0, 2, 0, 3. Why? The first number always 0? Because it's a zeros row. It's a first row. That's why there is a everywhere is 1, and it's a second row by index. So that's why this indexes is very important, and you have to work with them and try to understand what's going on inside of these indexes. So that's why this type of for loop will be used for looping over the two-dimensional array. So I and j, they will be the like indexes of the row and indexes of the columns. They will the rows. It's a columns. So counting a, instead of the row, we want to pass I. Instead of the column, we will pass the j. And let's put the space. 9 CPP. If you run it, you will have this such like a result, but we have here the extra one, which is not set by ourselves. Why? Because when we are creating the two-dimensional arrays and almost in creating the even one-dimensional arrays, if you don't set for some cells, some assigning them values, for instance, for these cells, we not set the values. When we are creating the inside of the int main, this type of the arrays, so this not set values can store the random numbers. So as you can see here, we have the not set 1, but we have the such like a value. That's why we have the two options. First one is manually setting all the values of this two-dimensional array to the 0. For that, you have to pay attention that I should work until the 3, because we have the 3 rows. So counting that we can do the counting, we can do this counting. We say that AI and AJ equals to the 0. So we are looping over the whole two-dimensional array and each cell assigning to the 0. And after that, we are just selecting the some needed cells and assigning the other values. And after that, printing out. So the printing out over here. So let's try to compile it again and run it. And you will have the zeros for other cells, and only those cells that we manually set the values will be appeared here. So this is one of the options. So one of the options, manually setting the 0. Another option, you can create the two-dimensional array before the main function. So if you have the constant values inside of the sizes, you can create them manually before the main function. But if you have to dynamically change it, for instance, here we have the n and m, which you will be get from the input. In that case, you cannot do that because n and m is not defined out of the main. So they will be inside of the main. Here we have the n and m and so on. But this is not correct because n and m is not defined out of the main. That's why if you have the constant values in a two-dimensional or any dimensional array, you can create them before the main function. In that case, you will also get the same result. So all the values by default, all the values will be the 0 if you are creating it before the main function. So if it's inside of the main function, you have to manually set it to the zeros if some of the values will be skipped for assigning the values. Okay. I think this is clear, and this one is also. So indexes very important, so you have to work with these indexes. So starting the table multiplication as a task for the table multiplication and working with the nested fors. For integer I equals to the 0. I works until the some number. Oh, sorry. Some number, but this number, let's read this number from the terminal. Integer n, sin n. Sin n, and I works until the n, I plus plus. And inside it, we have to write integer j equals to the 0. J also works until the n, j plus plus. And inside it, let's print out I multiplied n j. Printing out not handle, just space. And handle should be after the first for loop to print out as a matrix. Then CPP and writing like 5, writing like 10. As you can see, we have the multiplication table, but we don't need these zeros. That's why let's start from the 1. Oh, sorry, we have to compile it. For instance, 5, 10, which means 9 multiplied by 9 is 81. But this format is not comfortable for us because so the some numbers is 1 digit, some numbers are 2 digits, and so on. That's why you can manage these numbers so that this output, like using the configuration of the cout, we have the configuration like a width, and width function will take the one number. So this configuration says, so the output that should be printed out after this configuration should occupy as minimum 3 positions. If you run it, you will have such like a result. If you run it, you will have such like a result. Why? Because even we have the 1-digit number, we have to occupy the 3 spaces, 1, 2, and 3 as minimum. So this configuration, which is just outputting the format for our need. So let's continue. So the multiplication, I think this is clear. So finding the maximum element in the matrix. Finding the maximum element in the matrix. So finding the maximum element for that, let's use our free open 11th example. Let's put the free opens here and write our input here. We have the free columns, free rows and 4 columns. Let it be like this: -1, 2, 4, and 7, 9, 7, 2, and 5. So we have the free rows and 4 columns, and these numbers should be read from this file. This is our input, and you have to read it. So as you can see, the matrix size is not square matrix. It's just the n and m size. That's why let's create the 2 variables at first, n and m, and read them. So we'll read these numbers, and after that we have to read this matrix. So we know that matrix will have the 3 rows and 4 columns. That's why n rows and m columns. After reading the n and m, let's immediately create a 2-dimensional array with that size n and m. And after that, reading the content of the matrix. Pay attention that I should work until the n, and j should work until the m. Why? Because j is columns, I is rows. And inside of this inner if, we want to sing aij. So we are just one by one reading these numbers and storing them inside of our 2D matrix. It's a 2-dimensional array. So after reading the things, so this part will be the same for this type of indexes. So this type of inputs for all problems, you have to read it like this. And after reading the whole data, you have to find the solution for your problem. So in our case, you have to find a maximum element in the matrix. So any ideas how can we do that? Any ideas?
Use the loop and check every iteration if our E's and J's point in the matrix is bigger than before.
Firstly, let's create integer max.
Okay, let's create a max value. It should be equal to which number?
A0.
A00.
Yes, perfect. They should be the same logic as we did in a 1D array. So in 1D array, we did that like imagining that the first element of the array will be as a maximum and try to compare with the other ones. So here I have the same thing. So the 0, 0, which means A 0, 0 will be the maximum number. And after that, you have to compare it with the rest of the matrix. So instead of the same, we have to compare it. If ai and j is greater than maxi, in that case, maxi equals to the aij. After the whole comparison, see out maxi. So 11 CVP, if you print out, so the maximum is 45, as we have the 45 here. Let's write here the 3, and here we have the 45. If you run it, you will have the same result as before. And so I think this is clear for everyone. So you can think about it like starting from the 1 and 1. What will be in that case? Let's imagine. So if I am starting from the 1, I starts from the 1. In that case, I am skipping whole the first row. So I am working on in this section. This part will be skipped. So I'm setting as a maximum this number, but the rest of the first row will be skipped if I put I equals to the 1. So I will work only in this section. If j also will be equals to the 1, in that case, I will skip the first column. I will work in this section. By intersection, you will work only in these numbers. You will find maximum number only in this section, which is not correct for our solution. That's why I pay attention that you cannot start from the 1 and from the 1 for the I from the 1 for the j. It should be always 0 and 0, because we will have the rest of the row and rest of the column here, which you also have to compare with the maximum number. Okay, so let's extend this task and find the maximum element in matrix with row number, row and column number. So the output should be, if it's like this, so the maximum number is 45, and in the next line we have to write the number of row and number of column. Number of row is the first row, second row, and third row. That's why it's the second row and a first column, second column, and third column. So the column number is 3. So the result should be like this. So any ideas how can we manage this problem? So
just see out E, I, and J.
So where I have to see out? I have see out here. So
after maxi equals IAJ, break and count. Count maxi. Ой, нет.
So
ну, можно создать две переменные, которые будут отвечать за максимальный I и J. Вот этот.
Yes, this is the correct solution. So the row and column, the two variables which initially equals to the 0. Why 0? Because we are assuming that the 0, 0, it's a maximum element. So if condition is not working, so the row and column should be the same as we did before. So the row and column, so we define it over here. And if maximum was changed, we have to also change the row and column. So row equals to the I and column equals to the j, if I'm changing the maximum value. And at the end, I have to show the row and space column. But our rows and columns starts from the 0, but our output says it should be, for instance, 45 located in the first and second column. So they starts from the 1, because they don't know that our array index starts from the 0. That's why for others, this one is the first row and this is the second row. In other case, you can think about it like, so it's just 3 players, and each player will have the 4 points for each position. So this is the positions. So that this is the marks of the first player. This is the marks of the second player. This is the marks of the third player. And your task is find the winner of the game. So winner of the game. So who got the maximum mark? So the maximum mark got the second player. And second player in which position, in which stage? So the second player, which says 45, it's a maximum value for the game, and won a second player in the third position, in a third rate, so which means over here. That's why we have here rows and columns starting from the 0, and at the end, let's add just once. After identifying the maximum value, we have to just add once. 11 CVP and run it. And you will have the result 45, 45, 3, and 4. For instance, if it's here, you will have the 3 and 3. It's a third column, so third row and third column. I think this is also clear and we can continue working. So the time is okay. So the next example is so the I example. So example says you're given one number, n equals to the example is 3, and result should be something like this: 1 0 1 0 0 0 1 0 0 0 1. So you have to get one number from the terminal and print out such like a matrix. So you have to fill the matrix using this logic. So the main diagonal should equals to the 1, other values will be equals to the 0. So the integer n will be given for you. Sin n, and you have to create a matrix with the size of n and n, because we have the square matrix here, n and n, and fill this matrix using this logic. So any ideas?
Firstly, put zeros to each point of the matrix. Second,
Okay,
go through
find
the
it.
matrix.
Yes. Yes.
And if I and j are equal, put 1 to the i's and j's element of the matrix.
Yes, perfect. So let's open this second picture. So n equals to the 3, and we have the such like we have to get a such like a result as a result of the matrix, and here we have the indexes. So always when you are working with the two-dimensional arrays, please write on your papers or somewhere indexes of the matrix and try to understand what you have to do with the indexes. So we have this result, and this is our indexes, and we have to identify where I have to put the ones. As you can see here, all the positions where value should be the 1, I and j, they are equal. 0 0 1 1 and 2 2, and this is our solution. You have to just compare. If so, pay attention that both of them should be the n. Why? Because we have only one number and square matrix. We're comparing that. If I equals to the j, in that case I have to, so I want to put in that position of the matrix 1. Else I want to put 0. Else means all other cases, this one, this one, this one, and bottom side. Only the main diagonal should be equals to the 1. So we fill it our matrix, and after that let's print it out. For printing out, again we have to write the one more for loop. So a, I, and j, printing out the space between the values, and after the first row, print out the handle to start a new row in the new line. So the 12th example, 5, 10. So as you can see, 10 by 10 matrix, and fill it with our logic. So let's continue and extend this example. So in this example, you have to finish it like this. The bottom right side should be filled with the number of 2. Top right side. Bottom left side should be filled with the number 3. As this one, you have to select this segment as a 3 and this segment as a 2. So any ideas how can we solve this problem? So this section should be 2, and this
If
section should...
I greater than j, put 3.
Yes, perfect. Perfect, that's the solution. So if I, it's a first number, as you can see here, they're always greater than the second one. Second one is the j. If I greater than the j, if it's in that case a 3. Otherwise, which means if I is less than j, in that case 2. So let's add this example. So the 1 ij equals to the 1 will be the same as before. We have to add one more condition. If I is less than j, which is a number 2. It's the top side, top right side. In that case, we'll have to put 2. Else if, or just else, it doesn't matter. So for more understanding, let's put it like else if I is more than, so I is more than j, this is these positions. In that case, we'll have to put the 3. And that's it. Let's try to compile it. 5, 10. As you can see, we have this the solution for our problem. Let's continue. So the next example is opposite side of the eye. So the opposite side of the eye, which means the input is the same, but result should be like this. So the opposite diagonal should be equal to the 1 and other ones to the 0. So if you have such like a problem, immediately you have to write the indexes. So let's open and try to understand. We have the number 3 and we have here the indexes. And this segment should be selected somehow and set it to the 1. And other cells will be 0. Any ideas how can we solve this problem? How can I manage these sections with the condition?
Maybe if n minus I is equal to n minus j, we should fill it by 1.
So n minus j, for instance, n equals to the 3. N minus j here is 0, equals to n minus I. N minus I is 1, which is not correct. Let's think again.
Maybe inverse form of the array.
Inverse form of what? You should
Array. Matrix.
inverse form of array. So
Yes.
inverse form, it's yes. So it's correct, but it cannot be managed by one comment as you are expecting.
Can we write a plus j is equal to
A plus j.
is equal
Where-
to 2?
Where is
Two
the A? We don't have any A.
No,
We have I.
I plus j. Sorry, excuse me. I plus j.
I plus j equals to what?
Equals to 2. 0 plus 2 is equal to 1 plus 2 is equal to 0 plus 2 is equal to.
So we cannot set the constant number 2. What? How can I get a 2 from the number n?
N minus 1.
Yes, perfect. This is a solution. So the sum of the indexes equals to the n minus 1. So here I have 2, here I have the 2, here I have the 2. And if you see the other indexes, we don't have such like a connection between these two indexes. So if you are adding the indexes between each other, it will be the equals to the n minus 1. N in our case 3, n minus 1 is 2. So this is a solution. So we say I plus j equals to n minus 1. In that case, I have to put 1. In all other cases, I have to put 0, which means all other cases will have to put 0. So let's try to run it again. Okay, perfect. This is solution. As you can see, we have the correct solution. Let's continue this example and try to fill the rest of the code. Like here we have the 2's. Here we have the 3's. So let's think about it. How can I manage this section? It's a top right section and bottom left section. Oh, sorry, top left section and bottom right section. Here should be the 2's and here should be the 3's. So any ideas?
Where should be 2? Where should be 3?
So here we put the number 2 in this top sections will be number 2 like this, and bottom side will be set as a increase. How can I manage these sections? How
If
can I
I
stop?
choose j bigger than n, mean -1, it's be 3.
Okay,
А если меньше 2?
yes, perfect. Perfect, Ramses. So Ramses says about the finding the sum of the indexes as we did in the first section for selecting the opposite diagonal. So the I plus j. So here I have the I plus j, I plus j, I plus j, which is less than n minus 1. N minus 1 in our case it's the number 2. So if you find the sum of this section indexes, they will be always less than 2. On the bottom side, you will have the greater than 2. For instance, here we'll have the 3, you will have the 5, and if you have the more bottom sides, you will have always the greater indexes, so the greater numbers than the n minus 1. So else if I plus j is great, if it's a upside, top side, if it's less than n minus 1, in that case, I have to put 2. Oh, sorry. If it's a not, if I plus j is more than n minus 1, in that case, I have to put 3. 15th example, 5. 10. So as you can see, we have the correct solution for this example also. I think this is our last example. What else? Maximum, minimum location. So already we did it. So let's copy these titles here and write like a plan. And all other not finished problems you have to solve at your home and try to understand and discuss with your teacher during the practice lesson. Some of the problems might be in your lab works, and you can check your code in that systems, judging systems. If they don't have such like problems as listed here, you can discuss about it again in the practice or after the lecture time. So the symmetric matrix, so you have to identify is it the matrix symmetric or not. Finding the maximum minimum with the location. We already did this example. So when we are finding the maximum number, we already find the location of the maximum number. Maximum per rows. Maximum per row. So for instance, if you have the, so where is the input? If you have the such like input, maximum per row says output should be the 5, 7, and 35. So for each row, you have to find the maximum. So 5 here, 7 here, and 45 here. So this is a solution. So the output should be for this task. Finding the maximum per row. Finding the per row sum, which means you have to find the sum of all the values here. Find the sum and maximum between these sums. This is the last example. And simple version of the snake also will be finished and discuss it in a practice lesson. So snake might be fill it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So filling like this snake. If I'm entering the number, let it be, so one more. If I'm entering the number like this, 3 and 4. So 3 columns and 4, so the 3 rows and 4 columns, if I'm entering these 2 numbers, You have to fill the matrix in this format like a snake. So the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It depends on these numbers. So if it's a 4, if it's a 3, 3, in that case you have to continue 4, 5, 6 here, and this part will be the removed. 6, 7 here, 8, and 9. So this is just examples how you will get the inputs and outputs for your problems. So time to your questions, please. You can tell the number of the example and try to understand the question for your answer for your question. Raise your hand, guys. Время вопросов. Если у себя где-то отметили, можете спрашивать номер вашего примера и ваш вопрос. Так. While you are thinking about the tasks and questions, let me upload today's examples to the GitHub. With our images. So so the examples already uploaded to the GitHub. You can find under the link that was posted in the general channel. In the general channel, we have here the lecture notes. And in lecture notes, we have here the link to the GitHub. And in a week number 4, we have the group number 3, which is your group. And here we have the examples that we just finished today. So any questions? Okay, so it's a problem if you don't have any questions, because I think so the new title, today's topics will be the not a simple. So you have to ask the more questions. If you don't have now, please try to get the answer to your questions during the practice lessons, and asking them more questions from your assistant and teacher. Okay, let me stop the recording.